Let's review absolute values for the EOC. Right here I have the equation in vertex form for quadratics. And I wrote this down because I want to emphasize the point that there are many similarities between a vertex or a parabola and an absolute value function. To change from this to the standard form of an absolute value function, you only have to change three things. Technically two, I guess. So y, a is the same. The parentheses, each one changes into an absolute value bar, x minus h, and then this is to the first, so I don't write it, plus k. And I have my absolute value function. So what does each one of these points mean in each one of these? Right? Remember, in a absolute value and exponential functions, your h and k are your x and y of the vertex. Okay, remember h is negative, so you gotta flop it when you pull a point from here. Okay, and let's see, my k, like I said, is the y value of the vertex. The a value can tell you if it's concave up or concave up, or concave down. Concave up if it's positive, concave down if it's negative, right? And then it also, for quadratics, it told you the factor by which it changed. It'll stretch it or lower it. But it's even simpler for absolute values. This is just like a form of a slope, right? So with A, knowing it's concave up or concave down, and B, the actual number for A, you can figure out what the point's going to look like. So say I have a quadratic equation and it starts right here on the origin of 0 and 0, and we'll say it has a change in y and a change in x as 1, right, and it's concave up, so A is positive, right? So to start off my equation, I have y equals, my A is 1, so it's just A, but normally I don't write it, it's like invisible. Then x minus 0 squared plus 0 is my k variable, because my origin is 0 and 0. And then it goes up 1 and over 1, up 1 and over 1. This one would be 1 and 1. This would be negative 1 and 1. And this pattern continues infinitely, right? So it goes up 1 over 1, so it's 2 and 2. Up 1 over 1, so it's negative 2 and 2, right? And I have my v form from this, right? So to simplify this, like I don't, by convention, don't write ones if they're coefficients. So I get rid of the 1. I don't write zeros. Sorry, these should be absolute value bars. I don't write 0 if it's a term. So this is just the parent function y equals x. Okay, so what if I had a function like 3x 3 times the absolute value of x plus 2 minus 6, and this equals y. Okay, well, I know on a coordinate plane that this is going to start at negative 2 and negative 6, because it's the opposite x and the y. It's going to start at negative 2 and negative 6, so like down here. Okay, and my a value is positive, so it's going to be concave up, right? So I'm going to go up 3, 1, 2, 3, and over 1. Up 3, 1, 2, 3, and over 1. Okay, so this would be, let's see, it goes up 3, make it negative 3 over 1 becomes negative 1, and then it goes up and it's back on the origin. This one goes up 3, and that way 1. So it's still going to be negative 3, but instead of, it'll be negative 3, negative 3. And then this one would be at negative 6, comma, negative 0. Okay, so it would look like this. Okay, but that process, these are my x-intercepts, right? Because y is 0 for both of these. That process doesn't have to be as tedious as plotting points. There's an easier way to do it, right? I know I can pull the value of the vertex from that, okay? And I know that when my y value is 0, it equals the x-intercepts. So that is y equals, so 0 equals 3 times x plus 2 minus 6. Okay, so now if I solve for this, move the variables left, constants right, so it's negative 3 times x plus 2 equals negative 6. Divide both sides by negative 3. So x plus 2, absolute value, equals 2. Move the absolute value sign to the other side. And now clear the absolute values by forming two equations. One with the positive value of the absolute value and one with the negative value of the absolute value. All right, now solve, and I'm going to get, sorry, this should be negative 4. Goes over 1, negative 4. So now I just checked myself. All right, so now I have 2 minus 2, which is 0, and then 2, negative 2 minus 2, which is negative 4. So I was able to check my math there and see that I had made an error because negatives actually goes up 3 and then over 1 and negative 3 and then up another 3 and then over a negative 1 becomes negative 4. So I recognize my error by checking it with the algebra, which is easier and less prone to mistakes. Okay, so that is absolute value in a nutshell. But say, for instance, I get to a point like I have x minus 3 is negative 5, right? So this came from saying x minus 3 plus 5 equals 0. So this has a x at 3 and a y at 5, okay? And it's concave up. So this is my A, right? So A is 1, it's concave up, so it would look like this. So you notice it doesn't have any x-intercepts. It's 3, 5. There's no x-intercepts, right? So what happens with the math when I do this, right? So if I try to take the absolute value of both sides here to make it x minus 3 equals the absolute value of negative 5, well, I can't take the absolute value of a negative in an equation, right? That has 0 solutions, okay? Because it does not have any x-intercepts. And that's what it looks like on a table, right? So hopefully that makes a lot of sense. One thing to note, if you don't have an equation, just have an expression like 3 times x minus 2 plus 5 times x minus, or yeah, it's times x, that works, times x, right? It's not equal to anything, and I say, hey, x equals solve for f of negative 2, right? Well, this becomes 3 times negative 2 minus 2, which is negative 4, plus 5 times the absolute value of negative 2, all right? So in this case, this isn't equal to anything, so I can change that, the sign, I can change this to just a positive. So this is going to be 3 times 4, because the absolute value of negative 4 is 4, and that equals 12. That's going to be plus the absolute value of 2, 5 times 2, right? So that's going to be plus 10. So this is going to be equal to 22. Okay, so that's how you do it if there's no equal signs. Hopefully that makes some sense, and it helps.